All right, very good. Welcome, everyone. We will have two different sessions on this introduction to V9R4. I do want to mention up front that we will provide a link to those who are attending the webinar today and tomorrow. We'll provide you with a link to download this version within 24 hours of the second session. All right, so with that, let me get started. So this is RecurDyn V9R4 introduction. We will cover a variety of areas. So in the first session, we're going to cover the graphical user interface. We will also cover enhancements to the solver. And then in the second session, we'll cover MFBD, which is the multi-flexible body dynamics. This is our term related to the full flex module, which is the nonlinear flexible body. So we'll cover all those enhancements in session 2, and then also enhancements to all the different RecurDyn toolkits. So we're going to start here with the GUI. And first of all, just a brief introduction. There is a new plotting program that's provided with RecurDyn. It's called RecurDyn Post. And the purpose of RecurDyn Post is to provide plotting capability when you have many plot points. So we do encourage all of you with your RecurDyn models to use the plot multiplier factor and to generate lots of plot points, because when you have abrupt dynamic events, then to have an abundance of plot points makes it better for you to understand that dynamic event. The other thing about having many plot points is that in case you're worried about studying the vibrational aspects of your model and you want to do an FFT, then if you have lots of plot points, then you're able to see more information on the higher frequencies. So for that reason, or those two reasons, it's a good thing to have many plot points, but at the same time, to read them into RecurDyn, it becomes maybe a slow task. So to address that, we have the RecurDyn Post module. And you can see the basic layout here. Nelson Wu is going to give a presentation about this after my presentation, but just by way of introduction to just say, yeah, this is part of the release of V9R4 is to introduce this product. And he'll review all the aspects of how the screen is subdivided and so forth. And the plot package is fast. Because it's designed to be that way, but also there's an option to convert data. So Nelson will talk about that in some detail, and there's various scripting capabilities, and all this Nelson will cover. The user interface is a bit different than the RecurDyn post-processing, so Nelson will help us understand kind of the connection between what RecurDyn is doing as far as plotting and how the post package is handling that. So moving on to other GUI enhancements. First of all, related to the solid modeling aspect of RecurDyn, we have these CAD modifications. One of them is this new command we can see here, the fill hole command. So that's really a command that's used to stitch across an open surface, and so basically it will look at all the free edges, it will fill in a surface. As you can see in the dialog box, you can choose between a smooth surface or non-smooth surface, and so in this case of this empty box, in other words, a box with an open top, as we do a smooth option, then it's going to try to match the contour of the surfaces associated with the free edges. So that's why it comes up the way it does. And, it comes up with a pretty interesting shape here, but what it's doing is just trying to make the tangency match here of the new surface to the original surfaces. When you pick the non-smooth option, it doesn't try to match, the tangent condition there, so it's free to make an abrupt turn and have an angle, and so in that case, then it's just fitting a flat surface over the top. Okay. Why is it important to be able to fill in these surface holes? One important application is when you have geometry that you want to mesh and use with full flex, then you may want to defeature it. So this filling in of the holes is a one technique of defeaturing. So the second example here is that we have a wheel with some slots cut out, and so we can then see what happens when we give this command. Then those slots are all filled in, and then meshing should be able to occur across those boundaries. The second command is we have this new scale command. So you can pick some RecurDyn geometry. You can see here in the dialog box, you can pick this entity button and then pick whatever graphical entity. And then you can actually scale it independently in X, Y, and Z. Although most of the time these are probably going to be the same values, but you do have the option to change them. And then it will scale up the geometry. And then with that scaled geometry, then you're able to work with it however you would like. So I think the scaling can really allow for some interesting parametric changes and so forth, and I think can be quite useful. Okay, next geometry related enhancement is to be able to do pattern of geometries or a pattern of solids. So you can see here we have a solid that's this collection of tubes hooked together, so it's just a box with kind of just the edges. And then by using the pattern command, we were able to come up with the complex geometry shown on the right. When you do this patterning, you can do it with translations or rotations. And so if you look at this geometry that was created, here on the right, basically this is, several steps, and you can see, in each direction, there's patterning, in the depth, the width, the height, and so then those can be 3 different operations. Then rotational patterning, then you can basically pattern the geometry, around an arc, and so depending on models that you may be building up, this might be quite efficient to be able to quickly create a set of entities that follow, some kind of rotational or translational pattern. And then, this pattern geometry, each one is an independent solid, so then they can be edited separately later on, if you like. Next one is modification of local geometry. Basically, we have had all these different commands, and the scale is a new one. But what this enhancement here is that, as you can see in the dialog box, you can pick a solid, you can look at the different operations, and including the new scale command, and then you can go back and modify things. So that's really helpful, because in the past, you would basically have to kind of restart from scratch if you wanted to make a change. I mean, you could basically delete some of these operations depending on how you did them. So you wouldn't have to delete the geometry, but you had to delete the operations. And now you can actually edit these different local operations. So we have some new enhancements with regards to importing geometry. So in the case of CATIA point data, you have the option to convert these points into a marker. Each point can become a marker. And in the the import options, that you've had access, as it shows here on the bottom left, to work with the assembly hierarchy from the CAD system in order to combine solids into logical bodies. There's now a new command where you can actually create a translator log file. I mean, that's been on by default. So this new option is that if you don't want to see those translator files, you can turn off that option. So that's the import enhancement. And then in the user interface in general with V9R4, we've done a little bit of this in the past, but in this version, basically all the dialog boxes are now resizable. And so that gives you a lot of flexibility. And for those of you who are working with like multiple screens, this ability to resize and have things out there and convenient, can be really helpful. So so feel free to just check that out, and you'll see that the resizing is available for all the dialog boxes. And then when you do the resizing, also things have been carefully set up so that RecurDyn will remember what you've customized. And as you know, that's not been true in the past. Things would reset, but now this custom dialog box size is now retained, so that when you reopen it, it should be the way you had it. So that should help a lot. So there's been a lot of enhancements to the database window. And first one is you actually now have a search capability. So as you can see in the upper right corner of the database window, there's now a little search icon. And then you can type in the name of the entity that you're looking for. The second thing is that you've been able to see the different parametric points and parametric values in the database window in their own little group, as we can see here in the lower left. But now with V9R4, this is like a really smart enhancement. We're actually showing the values right in the database window, so you don't have to necessarily go into a separate dialog box to see what the values are. So in the case of these parametric points, as you see on the upper right, those are X, Y, and Z coordinates. So all those are shown. And then in the case of parametric values, it will, simply show the one value. The next enhancement is you can go directly to the motion dialog box you can now select properties, from, the motion entity. So if you can look to where I'm pointing, kind of in the center of all these dialog boxes, for a given joint, in this case revolute joint, if you expand out that entity, it will show you the base marker, the action marker, and then if there is a motion defined, it would show you this motion entity. So what's new is that you can now use this properties, you can click the right mouse button, properties will pop up, you can select that and go directly into the motion dialog box. So I think that can save a lot of time. Likewise, you can open the expression edit dialog box with the edit command with any of the entities that are listed under expressions, and it'll just take you directly to that dialog box. And also, there's now a new category for design variables. That used to be kind of mixed in with parametric values, but now it's its own category. So that's, I think, more clear. Zoom factor, you can adjust how aggressive zooming occurs as you operate your mouse or whatever your device is. And that's in the general settings for the display settings. And so then, you know, there's the default value is 1, but you can make it some other value. So to, you know, however aggressive you would like it to be, it'll follow along. So some of these devices have ways in their drivers to, you know, also control this, but this way you can just do it directly inside of RecurDyn, because maybe the zooming is comfortable with other software you're using, but you want to adjust it in RecurDyn, so you can do that separately. Okay, next enhancement is highlight line width option. So as you know, when you highlight something, then it will, you know, highlight it with a certain line. And it tended to be like a double width line. And if you would like it to be, you know, wider or narrower or whatever, then you can use this pull down menu to adjust the width how you would like it. This next one I think is really important and helpful, which is now you can display the magnitude of a force. I mean, you know, you've been able to define, you know, these force vectors and then the arcs to represent the torques. But now you can actually display the numbers, you know, go along with that. And so that, you know, just communicates more detailed information, you know, immediately with the animation. So I think that's really helpful enhancement. For a few releases, we've had these tags, name tags that you could turn on for the different bodies and different entities, you know, in a way to control what's being displayed. So the enhancement with V9R4 is that those tags weren't responding exactly properly when you were doing a cutting plane and basically hiding a portion of the model. So, you know, basically that's been corrected. So with the cutting plane, it will only show the labels that belong to the geometry that's being shown. And then the second thing is that there's been some improvements just on the readability of that name flag that shows up. I mean, when the body is being selected, sometimes the name tag was, you know, couldn't be read very well. So that's been fixed so that it remains clear whether or not the body is selected or not. The select list, select box, you know, those are very useful things. But what's been enhanced here, just to make the usability better, is that when you're in the middle of defining something and you need to select basically a numeric value, then it will make the select box select list inactive because it doesn't apply. So that just, you know, gives you that feedback that gee, at this point you don't want to be using the select box or select list because you want to put in some kind of value. So I think that's more clear. Okay, so on the ribbon, the main ribbon in RecurDyn, it's been in the display or in the settings area, that's been enhanced really to add one more dialog box and in doing so make things, I think, more clear. So basically what's new is that there's a new general dialog box that's separated from, you know, everything used to be in this display dialog box. And actually I think this is a bit historical because originally there was just one settings menu and it had display stuff and general stuff. And then later on we started adding these other settings, dialog boxes, and then but the display one then just took on this, you know, display, but it had the general stuff in it too. So, you know, now more appropriately, we have a separate general dialog box for the general settings. And so you can see now the different dialog boxes for general and display. You can see the different panels with the different tabs. So everything here should look pretty familiar because it was there before, but it's just regrouped to be more intuitive. So here's your general settings, model name, comments about the model. And then all these other options, are things that you've seen before in this display option. And then under display, the tabs are basically, view, geometry, and advanced. And so you can see how things are laid out, I think, in a pretty straightforward way. So I think it'll just be easier to find the option you want with this new layout. So I think it's a real improvement. When you're running a simulation, sometimes you want to pause. So there's this new option that you can actually save the RAD file when you pause. As you know, when you pause and then you want to, do an animation or do some plotting, especially if you have flex bodies, it will go through an operation, to, look through all the data and so forth. So that all this data is made available, and the RAD file is has the animation data, and so you can see all those all that animation information, but it wasn't RecurDyn wasn't saving the RAD file at that point. But now you have an option to do that, so that way, no matter what happens later on, if somebody pulls the plug on your computer or something like that, then the RAD file is saved, up through the point where you've reviewed it. So that's just a new option. And next one is, RecurDyn can import CSV files, for defining things like splines, and in some of the toolkits, there are certain inputs that can be done. So what's new is that the routine that's inputting the file now supports a comment character. So you can put in your own comments in the file, and that file can be read in without a problem. So I think it's a good idea to put in comments because you may want to archive some of this stuff, and then it's nice to have descriptions of what's going on embedded right inside the file. So now with this comment character, you can freely put in as many comments as you would like. You may have noticed that when you're highlighting certain things in the database window, when you select them, some things are highlighted, some things not so much, and especially with markers. So there's now an option to show the center of mass marker when the body is highlighted. And specifically the center of mass marker in the body. So, in the past, you would highlight or you would select this CM in the database window. It would not highlight, but anyway, you can now turn on this option to show it. And if you don't want to show it, then that's okay too. You just leave that or make that unchecked. There's a new close all command. So you can close all the different windows you have open in RecurDyn. So that's a convenience if you're ready to just shut everything down. So, this it shows here all the different options for close. So close all models, close all plots. So you can delete unused subentities. So, we started in RecurDyn being able to delete unused markers. And now they've added this capability to delete unused subentities. Subentities are all the things that are like non-graphical. So like parametric values, parametric points, things like splines. Anyway, you can see it in the main RecurDyn ribbon under the subentity tab. That you can see what all these subentities are. But anyway, in the database, it can be figured out which things are referenced and which things are not. So then you can delete what's not referenced. When you're in the spline, dialog box. With the right mouse click, there's now a new capability to copy and paste, the actual splines. So that can be very useful as you're creating things. If you want to create a variation inside of RecurDyn, so you can leave the old spline, make a copy, modify the copy, and then you could switch between the original and the modified copy freely and stuff like that. That's what that's for. There's a new filter function, and basically, it's for the relation map that can be brought up. And so sometimes in the database window, you may make certain entities inactive. And so this option here allows you to select whether or not you want to show those inactive items in the relation map. And that makes a lot of sense, because I can think of cases where I would want to show that stuff and other cases where I would definitely not want to see that stuff. And so now you can go ahead and just toggle that. So it's very convenient. Subsystem now has ability to be in a layer. And so, as you know, bodies and different things can be in different layers. So now subsystems as a whole can be in different layers, so that can make it very convenient to turn on and off display of a subsystem and things like that. There's been enhancement here in the tracing data when you're plotting. So you can see in the left, we have the dialog box for V9R4. So there's certain information being shown, and as you remember, when you trace along with the cursor along the curve, it will update X value, Y value of the nearest point, tell you what point that is, and give you min and max information on the curve and so forth. So now it's been enhanced so that now all these data entities are now in their own fields. And also it's added some information about the which point the min and max, where the min and max is occurring in the plot. So that can be really helpful, because you can export all the point data to Excel, or you might want to look at it in a tabular way and then pick out which point was the min and max and so forth for a given function. So that information is provided. This last one on this page, with Windows 10, there's this idea of Action Center notification. So, the Action Center will receive the entry, and it will say, oh, your simulation is finished successfully, meaning the RecurDyn simulation, and it will give some report on the runtime and so forth. But anyway, that will pop up. So, when things are running and you're working on something else, it's kind of nice to have that notification pop up, and it's using the native Windows 10 capability to do that. There's been a fair amount of work related to working with post-processing files. So there's a new capability here to regenerate the result file. And basically, the kind of thing you're going to do, one option is to merge files. Another one would be to extract files that are done, with a separate solver run of RecurDyn, in other words. So, for those who have been running the standalone solver, you may have noticed that the output files are organized a little bit differently than they are when you're just running inside the GUI in Windows. And the reason for that is that some of the post-processing is done inside the RecurDyn user interface. So there's not a RAD file when you're doing the standalone solver. It's a RAN file. The RPLT file is the same. But there's different files, and with the toolkits and so forth, there's some different things, flex bodies and so forth. So if you want to extract the result files from these other file types, you can do that, and that's basically replicating what would happen inside the RecurDyn user interface. You can also merge results files, several of them together. And so where, you want to do a simulation and logical pieces, maybe there's a series of assembly steps or a series of operational steps that you want to run separately. And then when you're all done, you can merge, everything all together however you would like to. So that's what this regenerate results files dialog box is all about, is performing all those functions. And you can see all the different options, picking min, max times and so forth. Anyway, so it's it allows you to put things together, and then that way you can produce a long animation if you need to for a presentation, or you can have a plot that includes these multiple steps and so forth. But it's you work with it as one set of outputs. We have some additional support on the Linux side, which is now with Linux, it supports network installation. So in situations where you may want to do a lot of client installs, you can do this, configure up this Linux network, and anyway, it supports this Samba server, and that can make things more convenient for your IT folks. RecurDyn now supports Visual Studio 2019 for user subroutines. So I have not tried this one yet, but the concept is that you don't need to have your own compiler, but you can actually use, I mean, you don't have to get like a separate compiler, but you can use Visual Studio 2019 and create user subroutines. And then third-party enhancements. So, we do these things from time to time according to enhancements that the third-party packages make. But also sometimes we don't change certain libraries, unless it's a major release, just to make sure things are very consistent from release to release. So in this case, we have this interop 2020 upgraded, and then the second one is the security, licensing is FlexNet. So basically saying that this version 11.14 is still maintained, but you have the choice. You can actually pick it when you're doing the install of the license server. You pick which FlexNet version you want to work with. So you can use the later 11.16.5.1. So you can choose which version of FlexNet you would like to use. And maybe your IT people have certain preferences. Okay, that's the GUI things. Of course, some of the GUI enhancements, influence the solver and so forth. But at any rate, now we will talk about the solver enhancements. This one, modifications are made in the solver, and then we get to see it in the user interface. But basically, with some of the contacts, with the geo contacts, you have the ability to define multiple contact points, and then we can look at force vectors. So originally, we would just see the force magnitude in the vectors, all the translational forces, and then maybe all the rotational forces would be with the arc, many arcs. So, but now you can show the different components. So the magnitude is the force vector option here. So that's still, an option. But then you can separately say, oh, just show me the forces in the x direction, y direction, z direction, normal force, or the friction force. And so that can be really helpful, because especially to separate out the friction force. So example of that is shown here in the right, in the middle. Sometimes to understand what's happening with regards to friction, it's really helpful to separate it out. You can look at the force vector and sometimes get a feel for what portion of it is friction, but once you get more than a few force vectors, it gets to be really tough. So now you can separate it out, display it separately, and really gain some intuition of what's happening in the system. There's a new constraint. It's a point to surface constraint. And if you look at the graphic here, we're kind of tracing a path on the surface, and it's like, oh, that kind of looks like a contact. So the idea here is that we want this to be a constraint that can replace a contact in certain situations. And the motivation for replacing the contact is that if you have situations where there's a contact going on, there's not liftoff, and you want to just have as fast of a simulation as possible, then to do it with a constraint versus a contact is a very appropriate thing to do. So it being a constraint, the idea is that, in this case we have some bodies. It's a spring-loaded body residing on this orange shaft here, and as you move the body with the surface, back and forth, then the tip here with this green-gray body is free to move up and down, with regards to the orange shaft. So that's, kind of 1 degree of freedom. And then as you move the surface around, it will trace a path, and that tip will always be following exactly on the surface. So this is very fast, it's very smooth, and so it's highly recommended to do this when you have these kind of situations of just wanting to follow an arbitrary surface, and it needs to be one of these UV surfaces, which are, a mapped surface, with segments, in a U and V direction. We have segments in each direction. So with that type of surface, this can be very efficient, speed things up, and also just provide very smooth behavior. There's a new function expression. So increment of an angle, or incremental angle, it's calculating the angle between markers. So if we look down here in the lower left and look at these vectors, so we have an angle between, the two different directions. One's marker 2 to marker 1, the other marker 2 to marker 3. So if we look at what is the interior angle in 3 dimensions, that's this incremental angle, theta. So, excuse me, if you don't have a, we have an option here to, in the expression, to name action marker, base marker, and then a reference marker. So if you don't have the reference marker, then it's going to just look at this overall angle. And as you see here, it's going to be a single value is shown in the scope. So this can be very useful, to just, track an angle, and just be able to define it very efficiently. This one is a really nice enhancement, and we've had this output request for a long time. Always we've had it, I think. And one of the options was an expression. You can define an expression output request. And then you would pick out expressions, basically, I think 6 at a time. And then they would be provided, as outputs to plot. But to define the output request, it really took, quite a few manual operations. So what's been done now is that in the expression list dialog box, there's a new column on the right called output, and all you have to do is check the box, and then that expression will be included in the plot data. So, this is showing the plot database window here on the upper right, and you can see there's this new expression group. And then, very straightforward because the names are exactly matching the names that are in the expression list. So you know what everything is, and then you can just click each one to plot it. So that should save a lot of time to set up those expression outputs. And, actually sometimes when I'm trying to understand some aspect of the model, I may have like a very complex expression and it's not working properly. So one of the things I do sometimes is, you know, I sit there, I mean, I try to visually debug it and often that doesn't work. And I don't know, you know, there's something, you know, some values going on that are just not what I'm expecting, but I don't know where the problem is. So I'll split the expression into, you know, I'll just make a sort of a copy of it and then take that copy and subdivide it into a bunch of independent expressions. And then I, you know, want to look at the plot data for all of them so I can get a feel for, you know, which piece of it has the unexpected values. Anyway, so with that approach and then being able to use this output option, then very quick to get all the feedback information you need. The solver has this new option that is going to be very useful for some situations where you're having problems with the model. And I think we all have run into the getting the message of RecurDyn stopping because the current step size is too small. And so what's happened, you know, historically, when the step size gets too small is the, you know, the last data that's recorded is the last, you know, standard report time. So as you run a simulation for a certain amount of time, you name, you know, how many steps you want in the simulation, which will then correspond with animation frames. You can put in a plot multiplier factor, which will tell you plot points, and then the reporting time will then reverts to being the, you know, interval for the plot points. So what may happen is you have a reporting time, and then you know, it starts going through some more steps. And actually, you know, between one report time and the next report time, you could actually have successful steps of the integrator, but it's, you know, we're just not recording everything, you know, in general, because it would just be too much data. So it's like we have the reporting time, and then we go through and the integrator takes some steps, and then maybe it takes, you know, the next step it takes, it hits a problem. So what happens is that if it hits a problem on the first try, so that's what this number one's all about, you know, this is corresponding to this red thing of it, you know, takes the big step, and then it tries to converge, it cannot. So then what RecurDyn does is that if it can't converge, you know, within a few iterations, you know, it's specified number of iterations. If it doesn't converge, then it will cut the step size in half. And then it will try to converge again. And so in this case, it cut the step size in half and it's like, oh, it converged just fine. So then it's like, okay, I took this size of step, it converged, I'll take another step of that same size. And this is, you know, try number 3. And once again, we're over here and there's something about, you know, maybe this point in time where something is amiss. Anyway, so, you know, the sub-step 3 also fails. So then it cuts the step size in half. So now we get to position 4, tries again, and it's able to converge. And so then it's like, okay, let's take another little step. And, you know, same as, you know, 2 to 3, 3 to 4, these are all same step sizes. So 4 to 5, same step size. We're back to the same point. Once again, it doesn't converge. Anyway, bottom line is that in the past, all you had was the information way back here from this report time. But now when this error occurs, so the current step size being too small, it will provide results from try or from substep number 2 and substep number 4. All the successful iterations will be shown. And then when whether you plot data or animate with time, you will see these last 2 steps, and that may provide some insight as to why things don't want to converge further along in time. So that's, you know, that's going to be really helpful for debugging. You know, I've used other software, and some of these packages, although well-known packages, you know, actually would fail, and there would never be any indication what was going on. And then I started using RecurDyn, and it's like, oh, that RecurDyn solver would just keep going even when I had misdefined various things, and I've had all the toolkits, you know, exploding, chains exploding, belts exploding, tracks exploding, you know, because I had misdefined something, and you know, RecurDyn kept going, so I had that feedback. So that was great. And so what this enhancement does is kind of continue that trend of trying to show as much data as possible, because there are some situations where the RecurDyn solver is going to stop, and this way we get as much information as possible. Okay, geosphere contact, we have a new options here for being able to create it, and you don't even need spheres anymore. So, you know, you can just go ahead and pick the surface of interest, and then whether, you know, you can do some kind of multi-sphere thing, but it's really multi-points, and then RecurDyn will create the spheres for you and set up all the different contacts for you. So that can be a big time saver. This is kind of a detail thing, but when you have you know, the geo contacts with many contact points, all that information is placed into the .con file. And what has been the case is when there was no contact happening at all, it was just left to be blank. But in some cases, if you want to do some processing on the file, it's better to have 0 values than no values. So there's an option where you can just turn that on. And there's also a new option for the geocontact results to be reported in the rplot file with respect, let's see, to the ground inertia marker. So you have some choices there of what the reference is with regards to the contact reporting. So otherwise, it's, you know, going to use the reference frame for the contact itself. So you have an option then of global or local type of referencing there. So that is what I have for today's session. We will have a second session and deal with those other topics. And at this point, I'll turn it over to Nelson for the presentation on the RecurDyn post.